Hi, my friends. I'm Mike Knoll, and my YouTube channel is Quality Mike 84. Today is Tuesday, the 18th of March, 2025. It's a beautiful sunny day here in Wiley, Texas, in the Northeast Dallas metro area, but it's windy. So you might hear some wind blowing past the window while I'm recording here. So today I'm going to talk about statistical process control, SPC, run charts. So this is not going to be a comprehensive lesson. In the period of time that I have with you, I'm going to try and give you just a quick idea of what SPC is and how it's used. To explain statistical process control, SPC, I'm going to present you with a little scenario. And then I'm going to give you some of the basics of SPC. And I've subtitled this, What Are the Odds of That? Because SPC does take into account probability. So here's the scenario. Jack and Janet are machine operators and they're making aluminum rods, and those have to be a specific diameter. Chrissy's the quality control inspector. So Chrissy holds a meeting. She tells Jack and Janet that the current acceptance rate is 90%, but she challenges them to increase it to 95% by next month. Jack and Janet go back to their respective stations. Now, Jack's strategy is to take a measurement every hour, and then he's going to adjust the machine up or down to get the perfect diameter. Janet, on the other hand, decides to take a measurement every day and then only adjust if the diameter is out of spec. The next month, Chrissy reports that now their acceptance rate is down to 75%. So, what went wrong and how could they do better? Some of the basics of SPC. This is based on the normal distribution curve. You've probably seen this before. And the more common measurements are here in the middle by the mean or the average. Less common measurements are at the low and high end of the measurements away from the mean. And here's a real world example. I got this from the cdc.gov website. This is the birth weight of babies in the United States in 2022. As you can see, the most likely birth weight of babies is between 3,000 and 3,499 grams. That's 6.6 to 7.7 pounds. Very few babies were on this top end, over 5,000 grams, 11 pounds. And also on the other end, very few babies were under 500 grams. That's 1.1 pounds. Lots of other kinds of data sets exhibit this trend, particularly when you're monitoring a process and you're aiming for consistent outcomes. About 68% of measurements will be in the zone closest to the mean. That's the green zone. About 95% of measurements will be in the two zones closest to the mean, the green and the yellow. 99.7 will be in the three zones, the green, yellow, and pink. And less than 0.3% will fall outside of those three ranges. That's shown in purple here. So the distance from the mean is measured in standard deviations, and we use the lowercase Greek letter sigma. So the green is plus or minus 1 sigma, green and yellow is plus or minus 2 sigma, green, yellow, and pink is plus or minus 3 sigma, and sigmas go as high as you want to go. The higher the sigma, the less likely that you'll find that measurement. And there is some math to this, but don't worry. Standard deviations can be calculated easily with Excel or Google Sheets. Now, SPC and normal distribution. Let's take this chart and flip it around. Here we go. So now we have it sideways with the measurement up and down. We'll add a new dimension, time. This way we can track our process measurements over time and watch for trends of common and uncommon occurrences. So interpreting the signals, I'm not going to read this whole thing to you, but for example, up here at point 16, we have a measurement that's outside the upper control limit. That indicates something unusual has happened that warrants investigation. There's other signals. For example, if you have 2 out of 3 points on the same side of the center line, further than 2 sigma from the center line, that means something odd's happening right there too. And then there's some other rules as well. So back to our scenario, Chrissy apologizes to Janet and Jack for not giving clear guidance. Chrissy decides to go back over the data and see where things may have gone wrong. So Chrissy pulls the sample readings of Jack's machine output for the previous month. It turns out that the acceptance rate of Jack's machine was already 99.5%. And even though this point is high, it's still within what you would expect. So when Jack made changes to the process when it was within the control limit, he ended up overcorrecting. And the acceptance rate for his machine dropped from 99.5% to 65%. And you can see this wild variation. On the other hand, Chrissy pulls the sample readings of Janet's machine output for the previous month. It turns out the acceptance rate of Janet's machine was already 80%. Now, the measurements were skewed high and trending upward. And since most of her daily measurements were within the spec, she didn't adjust very often. But the few adjustments she made helped a little, and her acceptance rate improved to 85%. So Jack reset his machine and then only made adjustments when the process was out of control limits. Janet inspected her machine and found it needed service. Once repaired, and after a month of proper SPC monitoring, her acceptance rate went to 99.7%. And there you go, my friends. That is a very simple explanation of statistical process control. And believe me, there is a lot more to it than what I've presented in this very short video. However, if you want more training on this, or if you need some help monitoring a process at your organization, feel free to give me a call and we can do a project together. So I'm Mike Null on YouTube. I'm at QualityMike84. Remember to help someone today and make all the good things happen. Goodbye.